triangles now instead of rectangles like we had in a prism. Okay? So when you start looking at these are probably a little bit more obvious, meaning what the base is. So when Riley was asking his question then before, there was a base, it just, in a prism, sometimes it's not sitting on the base, right? But it still has to be the base because it's the congruent figure. So that's where pyramids get to be a little bit simpler, okay? The other thing is we introduced a vocabulary word the other day, which was the slant height, right? Well, when you try to draw a, what do I want to say here? A pyramid. For me, these are even harder for me to draw. So I draw some kind of rectangle, and then I draw this, and then I'm going to go here and here. And then realistically, we should make those not be seen, right? And it's a little harder to tell when you draw it on this compared to when you have something like an actual figure of it. So when we're talking about the slant height, we're actually talking about this line right here from the vertex straight down to one of the edges of the triangles. And why we need this is to make that 90-degree angle there, right? Because if we didn't have a 90-degree angle, this wouldn't be a height. And in order to know what that area of that triangle is, we need a height and a base. Okay, so this is where the slant height comes into play. And the slant height is going to be shown by a cursive L. I don't know why. Right? But it's basically, so a slant height, if you really wanted it, is a segment from the vertex to the bottom of the triangle. And if we're talking about a regular pyramid again, or a right pyramid, what does that mean to you?
Regular polygons.
So the regular would mean that my base is a regular polygon, whether it's a pentagon, whether it's a hexagon, whether it's a square, right? A square would technically be a regular polygon. If that's true, then all of my triangles would have to be what? Congruent, right? Okay, so in a regular pyramid, or a right pyramid, the base is a regular polygon, and all triangles, which are my faces, are congruent.
This is still fault 2.
Still,
Okay, we just started.
we just started it.
It's 12:3.
12:3. Now, what happens if it's not? Well, in any of the cases, if it's not, then you can still have an oblique prism, or sorry, a pyramid. Now we're in pyramids. Or we could have just a regular pyramid, but one that's not, the base isn't a regular polygon. So again, remember, if you have an oblique pyramid, you're going to basically do the same thing, but like Riley said the other day, here's going to be my figure this way, right? So my triangle, or, yeah, that's okay. But it's going to look something, no, that's not okay.
It's not okay.
No, it's not okay. I don't know how to draw this one.
Just goes like this and draw it.
Do you like this?
Yeah, just
You think you know? All right, we'll try. So remember what an oblique one was? It's basically where we had it slanted, right? But, so like this side over here is going to be more pushed over to the side.
So now you have to be.
Now this one's probably easier to do in an oblique when we get to a cone than it is on a pyramid, but it'll happen sometimes too.
So would you just make the right?
That's just a
triangle?
normal obviously.
That, but this side is longer.
Well, yeah, so this side's pushed over there, right?
Yeah.
The whole thing.
Yeah.
It's kind of hard to draw. So we're pushing it over for an oblique one. But again, like I said, it's going to work more as an oblique cone. And then we would show you an oblique cone, which we'll get you to here in a little bit, would be this, right? That's what I was trying to draw at the beginning. So it's tilted over compared to a regular cone where it's exactly up and down. Okay, so the same concept happens with a pyramid. Well, so here's the question. If we base everything on what we talked about yesterday, and I told you that this base right here was the same as this base right here, right? And I fit this inside there. What's true about the surface area of my pyramid compared to the surface area of my prism?
It's gonna be
Smaller.
Okay, it's definitely smaller. Why is it half?
Because triangles are half of the thing.
Essentially, if you think about every face being a triangle instead of a square, and they were the exact same, cut out of the exact same piece, then this triangle right there has to be half of that square right there.
I remember in 7th grade when we did this, you filled up with a pyramid.
And we'll do that when we talk about body. But this is surface area now. But yeah, so that's the concept, and that's what, hold that thought, and we'll talk about that next week. Okay?
So regular polygons and all faces are to the left.
All those faces are congruent. All the triangles are the same thing. Okay? So, what's my lateral area of a pyramid?
Just the triangle.
So what are we going to use?
Would it be the
Base it exactly off of what we use for the lateral area in a prism.
Perimeter slightly.
Okay, so we would have set the perimeter times h, right? But now, we don't have an h, we have a what? Slant height. So instead of an h, we're going to have a cursive L. But then what did Chiron say? Divided by t. So you can either write it as 1/2 PL, or as Chiron said, capital P L divided by t. But essentially it's the same thing. And now we're still talking about an area, so remember that at the end, my label's still squared.
That's the final oblique pyramid.
Now this is just for a thing. If it's oblique, it's just tilted, and you're going to have to do different things for your faces.
Like you might have to do the thing right there.
Yeah, I might have to.
So
to
that's,
figure it out.
is that just like a regular one then?
This one right here?
Yeah.
Yes. This is for our regular ones. Okay?
How would you find the slant height
Of this,
of a pyramid?
of this in general, you might have to do the Pythagorean theorem. You might have to. A lot of the times they'll give it to you, but you might have to do trigonometry to it. And we'll show you that in an example. So then, what's my surface area? Well, the surface area essentially is the same thing, except what?
Now it's
To be,
P.
I don't know.
We're going to add 2b.
that's regular.
That's-
Just one, it just be big.
We're just going to add a b, though, right? Because why?
Because there's only one base.
Yeah, we only need one base now. So basically, we're going to still use my lateral area. So 1/2 PL plus, and then we're going to say capital B. But it's just capital B because there's only one base. There's not one on the top and one on the bottom.
The area of the base.
And this is the area of this. So capital P again is the perimeter of the base. And capital B is the area of the base. So again, this is why we can't just write it in there, because we don't necessarily know what the formula for the base is, right? So again, my base could be a rectangle, it could be a triangle, it could be a, maybe not a trapezoid probably, and then regular polygon. So you got to think about all those different ones. Okay? But now you're going to use the slant height instead. Okay? Questions here? Gabriel? Now that you know what the section we're on? You're okay? Do you want to do the problems now, or do you want to do the cone right away? Problems. So here's my first one. All right, so find the lateral area of the square pyramid. So first off, is it a regular pyramid?
No.
Yes, it's a square, right? If it's a square, it's got to be a regular pyramid.
I was thinking a house.
Okay? So again, you got to read the directions essentially. So notice here, like Gabriel asked, well, how do I find the slant height? Sometimes they're just going to give it to you. So this one's relatively easy because all the information is just given to you. So what is capital P in this case?
So 2.5.
2.5 times 4 gets me 10, and then I take 10 times 5, which is 50. Divided by 2 is 25 what? Centimeters squared.
So that's the lateral.
That's the lateral. So what do I have to add if I'm going to find the surface?
Area of the base.
2.5 times 2.5, or 2.5 squared, and I add that answer on. So what's 2.5 times 2.5?
A number.
6.25.
So 6.25 plus, what do we have in the first one?
25. So
25, so we get what?
31.25.
31.25 we should have. And then make sure you read the directions and see what they want you to round it to. Okay? Any questions there?
No.
So, where's the one I wanted to show you? Alright, perfect. So Gabriel said, well, how do if they don't give me the slant height? So notice here, now this is where it gets a little confusing. You got to really zone in at what they're pointing to, okay? So when they tell you that it's a square pyramid, but they don't give you the slant height. They don't give you the dark blue side on that triangle, right? The two pink lines are what we would have called an axis yesterday, right? From the middle to the middle, even though the altitude, okay? And so sometimes there's going to be an altitude, but sometimes the altitude and the height will be the same thing. No, the altitude and the heights are always the same thing. But sometimes if it's kind of oblique, my height could be the same thing as one of the slant heights,
The slant height is
if it's oblique. But again, don't worry about those too much.
yeah, but the slant height is the blue line, not the pink line.
Right, so my slant height is this line right here. So if they give me that the altitude, like Riley said, is 6, and the distance here is 4. Now here's the other thing that you got to think about. Remember when we talked about regular polygons, it was, how did we find the apothem? We drew a circle around there, right? And so when you draw the circle, or if you look at one of the lengths of a square, the length of this square is actually a diameter. Does that make sense to everybody?
No.
Because if I would draw a circle around the square to make a circle hitting the vertices of my square, the length of one of the sides would actually act as a diameter. Okay? And that's always going to be true. So that's where you can go back and you do regular polygons and use the apothem and
So
such.
could you use the altitude as a slant height then and do like
I can't use the altitude as a slant height because the altitude doesn't touch the triangle.
But couldn't you just do 8 times 8 times 6 divided by 2, since it's going to be half the triangle?
Why don't you just use
Stupid
Pythagorean
thing.
theorem with
Yeah.
6 and
4
4?
squared plus 6 squared equals
2 squared.
I don't say what you said again.
So 8 times 8 times 6 divided by 2.
8 times 8
Wouldn't just do these times, like,
for the surface area.
Yes.
I don't know if that works. You can see.
what was it? 8 times 8?
So
Times 6.
we'll check out what he's saying here in a second, and I understand what he's saying now.
I don't think it would work.
Okay, so realistically, you should go through the process of using the Pythagorean theorem. So if we have 4, 6, what's my hypotenuse?
7.7.
Square root of 52. Okay. What?
Yeah,
7.2.
Okay, so here's the thing that I would honestly do. If you have something like this, so in our calculation now, you found out that the slant height was the square root of 52, or you said 7.2.
Yeah.
Well, when I punch in the square root of 52, this is probably a rounded number, right?
Yeah.
So I would just use the square root of 52 in my calculation instead of rounding it. Or you got to punch in the square root of 52 and then use the whole decimal. Okay? But it's just as easy just to punch in the square root of 52. So when I'm going to do this now, what's my perimeter here?
32.
So I'm going to take 32 times the square root of 52 and then divide by 2. Or realize again, I can divide by 2 whenever I want. So realistically, I'm taking 16 times the square root of 52.
That'd be your lateral.
That's my lateral arc. Okay? And so this right here, I would add it to what?
64.
64, because that's the area of my base. And then I would do this right here and just punch all that in my calculator. So did your thought process work?
I don't know, I got 192.
So what's the answer?
179 is your 6%.
This is 179?
Yeah, the
Yeah.
lateral area is 115.
And so, no, it doesn't work. Okay? A great thought, though.
I think that was volume.
That's volume, of course. Yes. Okay. But does everybody see what happens if they don't give you a slant height? Okay? Good to go?
What was the?
Oh, you want to see the answers?
Yeah.
Well, I wasn't going to doubt Gabriel because you guys told me not to. 179.4.
So he was wrong.
So you were wrong. You said it was 179.
What's 179? I just didn't say that.
So again, then make sure that you pay attention to the directions to see what they want you to round to. Okay? So then we go to a cone, which is basically the same thing, right? In a cone, do I have a slant height? Absolutely. Right? So I still have a base and everything, and this is where you talk about an axis again, right? So in a cone, okay? So in a cone, we have an axis, just like our cylinder from yesterday, right? So this is an axis. But now we actually, what is given to us, that right there is our slant height. So again, the axis goes from the vertex to the center of the circle. Right? My slant height is still the edge. So here, you're probably going to do a lot of the Pythagorean theorem or trigonometry to figure out your slant height. But if it's oblique, I erased it. If it's oblique, then what happens?
And you're gonna have to get a triangle.
This right here is now my axis right here. Is that my slant height?
No.
So that's no
Slant height's the other edge.
Okay, so the slant height is still probably over here somewhere. So again, sometimes they're going to be oblique, and I think they actually show you some of these in this section. Okay, so again, now we're looking at right cones, or regular cones. Right and regular in this case mean the same thing, right? So if I have a right or a regular cone, and I'm talking about the lateral area, this is a little bit more simple again, because why? I always know what my what is. I always know what my perimeter is because I always know what the base of a cone is. So what's the perimeter of a cone?
Oh, it's just
5 times diameter.
2 pi r, or pi times diameter. Now listen, this is where a lot of the times, if you use 2 pi r, it's easier. Those of you that like pi d will show you this, but if you use 2 pi r and we stick it into this formula right here, we'd actually have 2 pi r, because that's our p, times a half, and then times my slant height. But what happens to my 1/2 and my 2?
It can be our
So they cancel out, and so a lot of the times, they're just going to say it's pi rl.
No,
Right.
you just say, well, it's not pi r.
It's pi RL, but if you're gonna do this as diameter, then you gotta do some work here. Because this would be pi DL,
And set that.
but then you're actually using that 1/2 in there. So I'm taking 1/2 of the diameter. So they just make it simpler by using pi RL. And this will be for every single cone that you can do, even if it's oblique, okay? Even if it's oblique,
That's pretty.
you're still gonna do it, right? So that's an easy one, okay? So then surface area is basically just as simple because why?
You're just-
We still have pi RL, because we bring that straight down. And then yesterday in a cylinder, it was 2B, but B, we always knew was what?
Area base.
And then what's the area of a circle? So, and then we can drop off the 2, so basically we just have pi R squared. So the surface area of a cone is pi RL plus pi R squared.
There's a lot of equations.
A lot of equations, you're right. That's the hard part for the test, to remember all those. Okay? So we simplify it to that. Any questions here? Okay, then let's go back and look at this. I think there's a couple good ones here.
Is that all the notes?
Unless you want to take down some other ones. Actually, I want to show this right here, if you want to write any of these down. Just notice this right here. See how it says find the surface area of a regular pyramid?
Yeah.
So automatically they're telling you that the base is a regular what?
Polygon.
But what is it?
It's a hex.
1, 2, 3, 4, 5, 6. So it's a hexagon. So when you're doing your 1/2 PA, remember that's where you have to find that central angle. And then you have to take that and divide it by 2 when you drop your or draw your apothem. So that's, I just wanted you to see that that's how you're going to do those. You want to go through all that whole problem?
Yeah.
Yes? Okay, so if I'm going to do this problem right here, watch this, I learned that I can just write on this instead. So, is this yours? Okay, so, well, yes, I knew that. So, what is my lateral area? They ask you for the surface area, but I still got to find the lateral area no matter what, right? So my lateral area is going to be what? 1/2 PL. So we're still doing that, and it's still relatively easy at this point because we're just filling stuff in. 1/2, what's my perimeter? Well, you might have to do that, right?
62.4.
62.4, and then what's my cursive L or slant height?
15.
15. So that one's pretty easy, right? That's pretty easy. So surface area, then we're going to use that same answer, but then now we're going to add what? My B, right? Which is the area of my base. So now we got to go back, and this is where this comes in. Remember this? Drawing that triangle there. So I have to take 360 divided by 6 because I want that central angle. Remember doing that? So what's 360 divided by 6? 60 is up here, but then I draw my apothem, and what happens to 60? So realistically, that was a bad one. I have this triangle right here, and this is a 30-degree angle, right? So I can use special right triangles. Now, what happens to 10.4? It also gets cut in half, so I get 5.2. So again, now what side am I looking for? This is 1, this is 2, and this is the square root of 3, right? So if I'm going from this side, I want this side or this side? The slant or the hypotenuse or the up and down one? The up and down one, I need the apothem. So how do I go from one side to the square root of 3 side? Whoa, what did I do there?
What'd you do?
I hit that button.
There's an exit
Come on, buddy.
Put your pen down.
there.
No, put the pen in the tray. Now tap it.
Oh,
you're playing through.
Press escape.
You went all the way.
Whoa!
That's right. That's right, though.
Oh, you have to take off the, you have to put it down.
Yours
Keep
going
going.
on too.
We're going backwards now. Oh, there it is. 1/2 PA. Okay?
They use standard.
They use tangent
Yeah.
instead of your special right
I
triangle.
did
Okay? Everybody okay with that though now?
too. So then we do.
Then you would take that answer right there and add it to that lateral area that we have.
Oh, so 9.
Oh,
So they got 9, yes.
That's 62.4.
And the grand total was
281.
right there.
nice.
There's your math.
So why'd you have to find that aquifer? Why'd you have to find that in order
To find the,
Because the area of a regular polygon is 1/2 PA. And A is my apple. Okay? Everybody cool with that one though? I know that one's kind of a little trickier. And then we want to go to a cone. Where's my cone? Well, this is an actual good one here. So think about this one right here. A sugar cone has an altitude of 8 inches and a diameter of 2.5 inches. Find the lateral area of the sugar cone. Okay? So again, Gabriel, can you draw this? Draw a cone up there.
oh god.
I'll try.
Or you gotta get out of the way so I can get in here. So you're gonna draw a cone.
Just take it out past the boulder.
Oh, that's fine. Keep going. There you go. Perfect. Now, it says an altitude of 8 inches. So where does an altitude go?
It's
In the middle, right? So there's my 8 inches. And then when he draws a line across, we don't have a what in this figure? A slant height, right? We don't have a slant height. We're going to have a radius because we can take the 2.5 and just do what to it? Divided by 2. So if 8's my up and down line and 2.5 divided by 2?
1.25.
So 1.25 is where?
Or 1.4.
Okay, so we're going to first do what? Pythagorean theorem to get our slant height, and then we should be ready to go, right? Okay? Does everybody understand that? So let's show it to you the rest of the way like this.
He draws now. He draws.
Come on. Oh, of course they didn't show me the answer.
So the slant height, you take that and you.
Come on. Maybe you can't. Oh, there we go. So there's my Pythagorean theorem to get my slant height. Okay? My slant height. Then I use that with my pi RL. R goes back and uses 1.25 as my radius. So I'm taking 1.25 and my 8.1 and times it by pi. So again, remember, you can still use 3.14 or the button. I'll do it, both ways, so you can do it however you want. But do not round until the very, very end. So like right here, I believe when you take this and square it, that's what you actually get when you add those up. Hard to believe that this is just 8.1. See how they still have that little thing? So again, this is where I myself would just leave this right here. I would leave that as the square root of 65.56 when I'm going to stick it into this down here, instead of trying to round that number or use that entire long decimal. You know what I'm saying there? Okay? And then after we get this answer, we're going to add it to capital B again, right? But capital B is going to be what? Pi r squared. And what's my radius again? We already found that out, right?
1.25.
Yeah, so in the cones and stuff, you get to use a lot of the numbers over and over again,
Wait,
which is kind of
you have
fast.
to add that to then the.
Yeah, whatever we got right here.
Oh, you have to add.
Should be 3.
I know, sorry, what did I say? I just said it, sorry. Here, how's this? Is that okay?
No, like up there.
I did.
Why do you have C right here then?
Well, I wrote B and then in parentheses I told you what B is.
Because these the pi
This
squared.
and B are the same thing. Okay? Everybody cool with that? And then again, the answers. And then again, make sure what?
Label.
That you have your label. And so then, in this case right here, that was funky. 31.8.
Yep.
And I think they only asked for the lateral on this one. So 31.8 square inches. We just went farther because we actually got the
Because we're
surface.
cool.
Okay. Okay.
That's cool.
So again, this one's a little bit more straightforward maybe, and shows you exactly what you might have to do, okay? So, do I have everything here? Do I have to do Pythagorean theorem in this one?
No.
No. Right? Because I don't need that dashed line up and down. I just need the slant line. So I really have all the information I need to fill in right here. Remember, this is my ultimate equation, right? Do I have an R? Absolutely. Do I have an L? Absolutely. And I already know what pi is. So I'm done with that. Okay? Questions there? All right. So as Ms. Warhoff asked, if you didn't hear, there will be a quiz over the first 3 sections on Monday.
All the formulas are in there. 858.
Oh yeah, and then yes, that was a good point. I think I had that in my notes, but there is a really, really nice synopsis of all the. Yeah.
Nice word.
Remember your vocabulary earlier, Ruben? I just showed you up with
Synopsis.
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 Get pooped on.
What does synopsis mean?
I don't know. Do you want one? Probably not. We'll probably have to just get into it. So yes, on page 858, there's a really nice chart of all of the things. And this is something that, honestly, you know, if you want to study things, this is where I would start studying, is by putting some time and effort